Oh, it's the best thing ever. Ew, you're a silent bunny. Ew. I love it when it's loud.
I cannot sleep when it's loud either.
Or the best naps are just like fall over in your house, and then there's like music playing with your earbuds in,
Okay, so page 3 is full. So page 4. I would like to say today is the last lesson, which is good. If you are done, like this is what we're doing is called analytical trigonometry. If you're like, I'm over this, we have a little bit of trig in chapter 6, bless you. We have a little bit of trig in chapter 6, but not really intensive stuff. So this is getting to the end of this. So we're going to put 1, 2, 3 things on here. So double angles, half angles, power reducing. These guys are in your book, but I decided not to do them because they're unnecessarily complex and I just didn't want to talk about it. That's honest. Yeah. So double angle formulas, there are actually 5. Okay, so we'll talk about how do you use them after we write them down. There you go. So cosine has 3, which is weird. They are just options really for you to use. Yep. Yeah, as soon as you introduce those fractions, it's not. Can you say that again? Yeah, it's the first one. Looks like it could be the big dog, but it's not.
I was talking about the figure.
Okay.
Yeah, the third one ever goes on squares.
Yeah, and I will tell you, actually, the way, maybe one of the reasons it looks like the big dog is because the original one is the first one. And then somebody said, hey, what if because this will have things happen, what if I substitute sine squared and I make that 1 minus cosine squared? Distribute the negative, and then what happens? You get one of those things on the bottom. Same thing with the other one. Oh, if I replace cosine squared with 1 minus sine squared, what happens? You get the thing on the third one of those. It's just different options.
Dude, they could have done something productive. This is what they should.
I think that cancer was not as common back then, so it wasn't the thing that they. Quite possible. Okay, so next thing I'm going to write down are the power reducing formulas. There's only 3. Could have.
And instead they were messing around with signs and numbers. That's not how we do right now.
There you go. So, honest, we're not using those power reducing formulas. I don't like them. Gets into some really complex trigonometry stuff. No, I mean, I want to say really, like not super really, but we don't want it. We just don't want to. Because if you were to go on from me and take a college calculus class, sometimes you have to use a power reducing formula. So then now I can say, I showed you those. That's all. Look, I showed you those. Okay. Listen, Javon, you're not going to remember this next year, let alone in 2. You can't, Eli. You know what? I'll be retired by then. You won't know my email.
We could find it. Literally everyone's information is online. Like if I Googled you,
I'm sure. Good.
your address.
You good?
I could figure it out.
Okay. These ones we will use, the double angles and the half angles we will be using.
Wed Mar's in that class. That's what you misinterpreted that.
Well, how did you want me to interpret that?
You literally wear sweatpants every day. That's how I'm interpreting that. It just doesn't give well the vibe.
It's cold outside, and I own 1 pair of jeans. What do you want me to wear? Shorts?
Sometimes
So
you
I'm
do
just
that
wearing my
too.
swimming suit.
You gotta have leather boots.
Yeah. I'm sorry, your Nikes won't cut it.
Wow, thanks, Ellen.
You're
So
welcome.
glad you did it.
Yeah.
Something I already know.
That'll keep you on.
Prefer to excuse, I feel like my speaks to hear her own voice.
Whoa. Speaking of, I feel like that's the pot calling the kettle black.
No, what?
What?
You've not-
You've never heard that? You've never heard the pot calling.
That's an old saying, because when all the things were cast iron, what happens to cast iron after you use it?
Oh,
It turns very black. So if your cooking pot says, hey kettle, you're really black, that's stupid, because so is the cooking pot.
It's like hypocritical.
It's totally hypocritical.
Yeah. Who is that directed at? Your Javon.
Javon. Because Javon said, or whoever it was that said, Ellen talks just to hear herself talk. Javon did. So, hello.
I'm like not registered. I'm writing it down.
No, that's fine. You just copy right now. We'll talk about how to use it in a minute.
Yeah, we have more.
Don't throw stones in the classroom.
No.
People
who live in
Glass
glass
houses. People that live in glass houses should not throw stones. I was summarizing it. Nice.
You guys are talking mumbo jumbo. I've never heard of it. You've never heard of it.
Mumbo jumbo.
Good. You're right. You guys have any questions? Or not questions? Are you good?
Yeah.
I got a guess.
I've been this church of the
It
last.
makes me say random songs.
Okay.
Intoxic health.
Yes, exactly. Sophocles type philosophy.
Can you restate the question? Have you ever what?
You want your toast things to do?
They were taking a philosophy class.
Yeah.
Yeah.
No, philosophy.
I wasn't.
Talking about whether or not
I hated both of them.
Why?
My mom didn't like philosophy.
Are you more of like a literal person?
I want you to take a guess just by this class. I want you to think.
I want you to think about that before you ask the
Like,
question.
okay, there's a certain point where you're like, I don't mind going, okay, these are the schools of philosophy. Like there's existentialist philosophy where you just talk about like, why are you here? Really, shut up and just be here. That's what I think. Like, why? Why do we have to ponder the meaning of life? Just get on with it.
Why is it 11? But what does time?
Because
Because I'm thinking about algebra.
Because like even if you cease to exist, like
Okay, Javon.
that just means that.
Also, my other Javon, that was one philosophy class. The other one was philosophical foundations of education, and it was. I want to poke myself in the eye. On top of it, it was an 8 o'clock in the morning class with the most boring professor, and that is probably the only time I've ever had a hard time staying awake in class. Like the notes would trail off the page because I was like,
That's what happens when I watch your videos.
thanks.
Actually, my notes No, watch. You can see the spots where I fell asleep and my pen just like bled off.
Yep, I get it. But I was in class when it happened, so
Is this?
I was pretty much Connor, but without my head down. No, it's 5.5.
Jason sleeps in class so much. I don't know how he is such a good kid.
He's got like an A and an A.
He gets like one question wrong on every single test, and that's it. The rest of us like got a 55%. He literally sleeps in class.
And half the time when he gets it wrong, he'll fight his cook on it.
Cool. Okay, so
Well, no, he won one time. He did keep that as you gave it. It was pretty funny. Yeah, well, he also went out. I see.
okay, so first one we're going to talk about are the double angles. So we divide this into two sections. What can you do with a double angle identity? And what can you do with a half angle identity?
Why are we doing shade back there, guys?
Okay, so listen, please. The idea is, with a double angle identity, you can take an angle and find whatever is double of it, hence the name double angle identity. We don't use this with the circle though. Okay, let me tell you why. Let me find my circle. Okay, like 30 degrees, I could find as double angle. But what's double of 30? 60. What's double of 45? 90. So we don't use the circle for this because everything that we would want to double is already on here.
Say it with 150% confidence.
Because confidence is key. Okay, so yeah. Even if I wanted to do, let's say I wanted to do 330 and I want to find 660. Okay? If I found his coterminal angle would be on the chart. Okay? So we do not use double angle identities on the chart. What we do use double angle identities for is with triangles. This is actually fairly easy. I think you won't mind this, relatively speaking. Okay, so let's say that cosine of theta is 5/13, and theta is in between 3π/2 and 2π. We're going to find sine of 2u, cosine of 2u, and tangent of 2u. Theta, sorry. Okay, so first of all, I want you to look at those formulas. We got to have all the pieces, right? We got to have a sine and cosine, sine. But here's what I want to show you. The reason that there's a couple here is because you have choices. If I said to you, only find the cosine of 2u, and you have the cosine of u, then you would use this one, this middle one, because then you don't have to find any missing pieces. You just use the cosine. Okay, but let's find them anyway because we're going to use them. Okay, so go ahead and before I do anything else, I want you to find the sine of theta and the tangent of theta for me. Not these guys, but from the original.
No. Third quadrant.
Nope.
Fourth quadrant.
Fourth quadrant.
That's what I meant.
Yep.
They're both negative. Sorry.
Yep.
So they're all negative.
Okay, so what's the sine of theta? What's the sine of theta? Yep, -12/13. Okay, we know he's negative because it's in the fourth quadrant and this missing side is 12, so opposite over hypotenuse. What's the tangent of theta? Yes. Okay. So that's the hardest of the work that you have to do. The rest of us is following formulas. Okay. So sine of 2 theta is the top one. So to find that is, we're going to do 2 sine theta times cosine theta, because that's what the formula says. Okay, so it's 2, because 2 is 2. What's the sine theta? I have 12 over 13. And cosine times the cosine, which is 5 over 13. Okay, now when you multiply this guy right here, this is 2 over 1. So remember that's 2 over 1, because when you're multiplying fractions, it's top times top and bottom times bottom. It's not 2 on the top and 2 on the bottom, because that would be 1. It's 2 on the top and 1 on the bottom. So multiply straight across the top, multiply straight across the bottom, and you're done. Do it in a different order. Do 2 times 5, because that's 10. Yep. 169. Done. Okay. This is easy. Okay. Totally easier than the other ones.
Yeah, but this is like easy until we get later.
Okay. So cosine. So you guys, you can choose for cosine. It does not matter which one of these 3 you choose. Okay. I'm gonna do the middle one. Okay. Because, and the only reason I'm gonna do that is because I like the looks of that fraction better. Right? There's no good reason other than that. So this is 2 cosine squared theta. So we need to remind ourselves of how we do that, minus 1. Okay. When you talk about cosine squared, it's the cosine squared. I know. So it's written like this, but the cosine itself is 5 over 13, and that's the thing that gets squared. Okay, so let me remind you, when you square fractions, you square the top and you square the bottom. So this fraction, 25 over 169. Okay, now let's do this in one step. We're going to have to combine fractions here, but that's okay because it's a 1. What is 1 going to be equal to? Common denominator wise. 169 over 169. So you might as well do that. Okay, so this first fraction is what? $50 over 169 minus 169 over 169. Negative 119 over 169. What? You good? Okay. Okay, so let's talk tangent. This is not going to be terrible. I promise this does not seem as bad to me as the ones that are on the chart. So the formula for tangent is 2 tangent u, or theta, sorry, over 1 minus tangent squared theta. So I have our tangent. Tangent is negative 12 over 5. Pop them into the right places. Negative 12 over 5 squared. Okay, so let's multiply the top. What's the top multiply to? Negative 24 over 5. Okay, bottom's going to require just a smidge more work. Okay, what's the fraction in the parentheses? 144 over 25. Okay, now, common denominator, you guys, I'm going to be honest, I never do this in two steps. I always do it in one. What does this 1 turn into?
25 over 25.
Right, 25 over 25. So now I can just do this. This is negative 24 over 25. And that is, Javon, you said negative 118? I don't think that's right.
Yeah,
Okay.
it's square the bottom.
Because you square the top, you square the bottom. When you square this fraction, so let's see, Kira, this is positive 12, or it's negative 12 squared, and it's 5 squared, so 25. Yes.
Yeah, but what's the top fraction?
Oh, why is it top 1 over 25?
Yeah. It was 5.
I have 5. Wait, yeah.
Because I screwed it up. There you go.
That makes
How about that? Okay, so keep switch flip. So negative 24 over 5, and then 25 over negative 119. Now, you guys, I'm going to show you this. This always happens. If it does not happen, listen, if it does not happen, you screwed up. Okay? This will always reduce with this. Okay, so you can do 25 divided by 5. What is that? 5. So this can turn into 5. Because you just do 25 divided by 5. Okay, so then this is negative 120 over negative 119, which is 120 over 119. Now, I'm going to show you a hack that's going to save you a boatload of time. The hack only works if you had to find all 3. So if I just gave you, hey, here's this, find the tangent of 2 theta, you're out of luck. But if you have found the other 2, I want to remind you that tangent is equal to sine divided by cosine. You guys follow me? So you could absolutely do the sine, negative 120 over 169, divided by the cosine, negative 119 over 169. And then you can keep, switch, flip, and you get those cancel, the ones can't, or the negatives cancel, and you have 120 over 119, which is significantly faster. Okay, so as long as you have the sine and the cosine, you can use this. That's a fair thing. Okay, as long as you have the sine and the cosine of 2 theta, you can do that. You could do that with what we did yesterday, with those like sine of u plus v. If you had to find sine of u plus v and cosine of u plus v, you could find the tangent of u plus v the same way. You could do the sine divided by the cosine. Okay. Do you have any questions on this? I don't really want to go over any more of these because they're the same. Okay. It's easier than we're not done. We're not done. I have 4 minutes. Do you have any more of these? No, I didn't do any more of these. Okay. Nice try. You are funny. Okay. So, solving. Okay, so here's what I want to say about this one. This is the extra credit on the quiz and the test. I can't remember if the quiz for sure, but definitely on the test. Okay, one or the other. Can't remember. I'll be honest. Can't remember. But it's an extra credit on either the quiz or the test. Okay. So we are going to do one example of this. Okay, so here's the problem. Here's the problem with this. You cannot solve an equation that has a plane x and a 2x. Okay, so this is a no-go right here. This is the problem. So what you have to do is use the double angle identity to get rid of sine 2x.
Or reverse, we have reverse law.
Okay, so sine of 2x can be replaced with 2 sine x cosine x. Yep, use the double angle identity. Yep. What the double angle identity does when you use it here is it gets rid of the 2x and replaces you with just a plain x. Now you have a multiple things you could do. Honestly, you only have one thing you could do, but not just that. You have to. That's the way you have to solve this. Now you can say, oh, I have a cosine in both spots and the 2's, so I'm going to undistribute 2 cosine x, leaving you with what? 1 plus sine x or sine x plus 1. Yeah, now you solve it. Just a reminder, how do you solve this? Each of them equals 0. So 2 cosine x equals 0 and 1 plus sine x equals 0. Okay, we're not going to finish that because it's extra credit, but I want you to know that that's a thing because that's on the extra credit. Okay, you may put your calculators back, get your phones.
I got stuff.